everyone. I hope you've had a great week so far. Thank you so much for coming for the last session at Ignite. I really appreciate that. So today, I hope you get some great takeaways from this session. We are going to talk about enhancing app quality and reliability with Microsoft Testing Services. I'm Nikita. I'm a Senior Product Manager at Microsoft working on Azure Load Testing. And in the next 45 minutes, I hope you're able to take away some great learnings from this session. So let's get started. Over the next 45 minutes, we'll look at how you can make sure your app is of high quality, high performance, and resilience. We'll start with the need for quality and reliability in real-world applications. We'll then look at an e-commerce application and see how you can make sure it's of high quality with end-to-end testing. We'll also look at how you can ensure that your app is able to take the peak traffic and how you can improve resilience by simulating real-world outages. So how many of you have had an experience where you go onto a website and you click on something and then you see that's a weird error that comes up? I'm pretty sure a lot of us. Also, we've also experienced things like you're trying to buy something during a sale, but the app or the website is not letting you in. That's due to high traffic and the app not being able to support that. So we've all had such experiences. Some of these experiences that you see here are the things that have come in limelight. And as you can see, one of the well-known social media company during the rebranding introduced numerous UI bugs, including like broken links and stuff like that. We've also seen a ticketing service company during the pre-sales of a famous celebrity concert did crash multiple times, and that also was a disaster. We also saw a famous social media company again had a massive 6-hour outage due to some configuration changes. So things like that have been common, and this leads to a very bad user experience. It can lose the trust of customers, and also and could also can lead to loss of revenues, which is really bad for businesses. So what do you need to do to make sure your apps are future ready? You need to make sure your app has seamless customer experiences. It does not have any buggy UX. You should make sure that it is ready for peak traffic, it is reliable, and you have some disaster recovery management in place. Always we have to make sure that your apps have continuous validation so that there's no regression and you can catch these any issues early in your development lifecycle. So how can you deliver robust and reliable applications? Well, you can use Microsoft Testing Services to build and deliver reliable apps with confidence. Today, we are going to talk about 3 such services. The first one is Microsoft Playwright Testing. Microsoft Playwright Testing enables end-to-end web testing to ensure high quality. The next one is Azure Load Testing, which helps you test your apps for high performance. And then we have Azure Chaos Studio, which helps you prepare your apps for any disruptions. So let's take a look at what we are going to test today. So I have an e-commerce application. I'll just switch to that. So this is Contoso Traders. It's a demo website, but it's actually an e-commerce website where you can purchase all your cool gadgets. So I want to make sure that I want to test this website today. This is my GitHub repo, which has the source code for my Contoso Traders website. And I'll just walk you through quickly how the architecture looks like for this. So it has different microservices, but we'll look at things that we're going to focus today. It is mostly the front end is hosted on App Service. And we have some APIs. The Carts API is on Azure Container Apps with the Cosmos DB. And the products API is on Azure Kubernetes Service with Cosmos DB and SQL DB. So today, mostly we are going to focus on the products DB. So we'll take a look at how the products DB is going to perform today. So first thing first, I want to make sure that my app is of good quality. So when it comes to quality, we are talking about end-to-end UI testing here. How many of you have heard of Playwright? Yeah, I guess Playwright has become very popular in the recent past. So Playwright is an open source framework that is developed and maintained by Microsoft. It enables you to test your web apps across all modern browsers. It also has multiple language support, so you can write tests in the language of your choice. It enables you to run tests using parallel browsers, and also has a lot of powerful tooling inbuilt. For example, CodeGen allows you to record and replay your scenarios and get a test script out of it. And TraceViewer helps you debug and troubleshoot your tests. So we'll switch to a quick demo to see how you can have your Microsoft Playwright testing enabled. So I have a GitHub repo. So I can run Playwright. So Playwright, as we said, is an open source framework. So you can run Playwright tests on from your local machine using VS Code, or you can run it using a CI pipeline. So I put it in my CI pipeline here, and you can see we see some tests have failed. But what I want to highlight here is that you see, this is a very small website that we have. It's a demo website, so it does not have a lot of scenarios. But just for this small website only, I had to run this test, and it took me like 4 to 14 minutes to run the test. The reason is that now when I run these tests on Playwright open source, it's actually spinning up browsers on my CI agent or on my local machine. And you can only spin up a few browsers on your local machine because browsers are resource intensive. That means that tests take longer to run. Imagine a scenario where you're running your tests for a real world application and it takes hours to run. And if you are running these on every pull request, that means that the developer has to wait for those tests to complete every time they raise a pull request. So that leads to slowing down the development process. So what is the solution for that? Microsoft Playwright Testing is a managed solution that extends the Playwright open source framework. So Microsoft Playwright Testing gives you cloud-hosted browsers. That means your local machine can now connect to browsers hosted on the cloud, and it can now run tests in parallel. That means that you're speeding up your CI validation, your PRs run very fast, so it basically accelerates the development process. It also gives you multiple OS and browser combinations. That means you have improved test coverage. The service is fully managed and has reliable infrastructure, which helps you test your apps with confidence. It also has rich troubleshooting and debugging capabilities with the reporting functionality that Microsoft Playwright Testing offers, which we will see in a while, that helps you resolve issues very faster. So let's now take a look at Microsoft Playwright Testing. I'm switching back to my repository. So we saw this run, which ran with Playwright open source. Now we'll go back to a run where I ran the same tests, but I ran it with Microsoft Playwright Testing Service. So as you can see, in this, it hardly took like 1 minute, or 1 minute, a little above that, to run the same test suite. So you see the significant amount reduction in the amount of time it took for you to run the tests. So this is where Microsoft Playwright Testing adds a great value. Now we'll take a look at how you can set this up and how you can run these tests in Microsoft Playwright Testing. And we'll also see how you can debug the failed tests and understand what was the issue. So you can go to playwright.microsoft.com. and create a workspace. You can just create a workspace here with your Azure subscription and the region you want to create the workspace in. And once you create that, you will have a view where it explains you how to get started. It's very simple, few steps where you install the package and you set up your authentication. And then you can actually run these tests on Microsoft Playwright Testing. There's a configuration file that is created for Microsoft Playwright Testing. And you see this, you can mention the number of workers you want to run the test with. So this is the test that ran. I ran this with 30 workers, and I see that, let me just show you that. Yeah, I ran this test using 30 workers, and that's the reason why the test took very less time. So there were 30 parallel browsers that were running my Playwright tests, and that means that I was able to complete the test runs faster. I can show you what the results look like. We'll just take a look at the results. So I have a couple of runs here. Let's look at the one that came from my GitHub workflow. Yeah, so this is the run that we saw. We see that there were some pass tests and there were a few failed tests. So I get this view where I can filter it by the results that I want to. Now I want to understand what happened with these tests and why did it fail. So I can just click on any of the tests and I get to see a view of what the test was trying to do. As you can see, it was trying to find some text on the screen, but that element was not found. And then it also gives me like the screenshot of what the test page looked like, and also a video of what happened during the test. Not just that, we spoke about trace viewer. So you can click on the trace viewer and hover and see what happened during the test. It gives you the timeline view, and it also gives you all the logs on the browser where this test was executed. So you can see that the error, console, network, all of these logs are available for you, and that makes it very easy for developers to go and figure out what went wrong and how they can fix their code. So Microsoft Playwright Testing allows you to debug, troubleshoot, and then you can fix these issues. So I was able to understand what went wrong, and I fixed my issue, and I got a run which actually passed. So you can see that I had all my tests passing here. So in this way, you have a view of all your test runs here, and you can see how your apps perform, your app quality was over time. So that's how Microsoft Playwright Testing enables you to run faster tests, troubleshoot, debug, and test your app with confidence. Let's see what happens in the background when you run tests on Microsoft Playwright Testing. So this is what the high-level workflow looks like. When you trigger a run from, say, your local agent or your CI pipeline, and you run the command npx playwright test with the number of workers, the Playwright test runner has now spinned up 30 workers. As you saw, we had 30 workers that I mentioned in my Playwright pipeline. So it spins up 30 workers. These workers are lightweight processes and don't take up a lot of resource. So what they do is each worker connects to a cloud-hosted browser, and these browsers are actually executing the test. So in this way, the CI agent is able to connect to multiple cloud-hosted browsers. At the end of the test, the local machine or the CI agent can also upload the test to Microsoft Testing Services for the reporting functionality. So the demo that we saw today was using the Playwright runner, but I'm very excited to announce that we have now released the support for NUnit test runners. So .NET developers can now run their tests using Microsoft Playwright Testing, and they can use the NUnit test runner for that. They can make use of the parallel browsers, multiple OS and browser combinations, and the rich reporting and troubleshooting functionality of Microsoft Playwright Testing. You can learn more at this link. There's a blog post which talks about the end-to-end scenario. So now that I have looked at how I can make sure that I'm testing my app for its functionality, I'm doing my end-to-end UI testing, I want to now look at performance. So we know there's an upcoming Black Friday sale, and I want to make sure my website is able to take the load for the Black Friday sale and make sure that it's able to perform when there are simultaneous users actually concurrently using my website. So I'm going to use Azure Load Testing for that. Azure Load Testing is a fully managed service that enables you to generate high-scale load with ease. That means that you don't have to worry about managing the infrastructure that is needed for you to generate load. So all the load generators are spinned up by the service, and it takes care of managing, provisioning, deprovisioning those load test engines, and you don't have to worry about it. You can run your existing scripts on Azure Load Testing. For example, Azure Load Testing supports Apache JMeter. If you know, Apache JMeter is a widely used load testing framework in the open source community. You can just plug in your scripts and run that. Or we also have recently added support for Locust. Locust is a Python-based, developer-friendly load testing engine, which also allows you to generate load. The other option is you can just get started in the product, give your HTTP requests, URL and the requests, and get started from there as well. Azure Load Testing also helps you identify and fix any performance bottlenecks. So we'll take a look at the demo, and we'll see how you can use the metrics that it provides to identify where exactly is your performance bottleneck and how you can fix that. It also integrates in the developer workflow, which helps you perform continuous validation to make sure you catch any performance regressions early in the development lifecycle. So let's switch to a demo. I'll just take you through I have the same repo, by the way, which I had for my Contoso traders. I have cloned it into my machine, and I have my VS Code open here. So this is the Locust script that I have. It's a simple script because the website is not a very complicated one. It's a simple one. Just calls the home page. And then it calls a few of my product APIs. Now, product APIs we saw is deployed on Azure Kubernetes Service. So we'll take a look at how my product API and my app service is functioning when I simulate load. Now, I could also run this Locust script on my machine, but again, we have the same problem that I'm constrained by the resources that I have on my machine. The CPU and the memory would not be enough for me to generate load onto my endpoints to make sure I'm generating high scale load. So what I'll do is I will upload this onto Azure Load Testing and run this there. So let's go to an Azure Load Testing resource in portal. This is the Azure portal where you can just search for Azure Load Testing, and you can create a resource and get started. So as you can see, you have a few ways to get started here. You can either add your HTTP requests directly here in the portal and get started. It's a UI that you can use to get started. Or you can upload a JMeter or a Locust script here. So I'll take a look. I'll show you what my test looks like. So I had configured this test to run on Contoso traders. This is my test plan. I have uploaded the Locust file that we saw just now. I have uploaded my test script here. If you have a JMeter file, you can upload your JMeter file. Any other files that you have, for example, if you have any test data, you can upload your CSV files here, or any configuration files as well can be uploaded here. So I'll want to focus a little on the load tab, which is because you can actually unlock the potential of a cloud-based load testing service here. So you can select how many engines you want to run the load test with. That means engines are load generators. So how many load generators do you want to spin up in the test to generate load to your endpoint? Azure load testing supports up to 400 engines in a single test run. So you can actually slide and choose how many you need, and that is how you're able to scale out and generate high scale load. So it's as easy as doing that. You don't have to worry about spinning these up and managing them. Here I have also provided how many users per engine. So I have provided 500 users per engine, and that multiplied by the 3 engines that I'm running will give me like a 1,500 concurrent users accessing my website. The other thing that you can also mention is if you want to distribute your load across different regions. So for my Contoso Traders website, I expect load to come from traffic to come from different regions across US. If you have a global website, you can add regions across different regions in the world, and that will show you when the test runs, how was the latency and how was the performance in different regions. So you can actually split and view the metrics for different regions. Azure load testing, by the way, supports 19 regions, so you have good global coverage. Now let's look at monitoring. So since my app is hosted on Azure, I can add my application components here. And what happens is when you run the test, you can actually view real-time metrics of your application. For example, for my app service plan, I can see what was the CPU utilization, what was the memory utilization, and I can see all those metrics as well, in addition to what the client side metrics look like. So I do get the response times and the error rates and latency and all of that from the client side. But since we have an integration with Azure Monitor, we also can pull the metrics from Azure Monitor for these server-side metrics. And finally, I can define what is my test criteria. I can do this on the client-side metrics, like, for example, you have error, latency, response time, and all of those metrics. And we also can do this for the client-side server-side metrics. So for example, if you say you want to say the app service plan, I want to add a metric for my CPU utilization, you can add that. And you can define what is your threshold for that. What happens at the end of the test is these metrics are evaluated, and the test is either failed or passed based on that. So now I have set up my test. I'll take you through a test run. I could trigger a run, but that would take some time. So I would like to take you through the test runs that I have done earlier. So I think yesterday I was able to run a few tests, and this was the first test that I ran on my Contoso Traders app. So this test, as you can see, failed. And now we'll try to understand what happened and why this test failed. I see that the error percentage was quite high. I had defined my error percentage to be, the threshold to be 2%, but it exceeded that, and that's the reason I see that this test has failed. I can go ahead and see the metrics for each of the requests that I have in my test script. So it gives me the breakdown for each of this. And remember, we added multiple regions to my test. I can also view how was the performance in different regions. So I can see the latency, the error percentage, throughput for each of the regions to understand if my app is performing as expected. So since this test failed, let's go ahead and debug what happened. I see this is the load. Virtual users is the number of concurrent users that I have had at that time on my website. So this did ramp up to the 1500 that we configured. And I also see that the response times actually significantly shot up, especially for the product details request. I see that the response time was quite high. So let's try to understand. We also see that there were some errors. Actually, there were quite a few errors that were reported in this test. So I want to understand what went wrong. So let me look at the server side and try to understand from my app components if something went wrong over there. So I see that these are my app service metrics. I see my app service plan. My app service plan was fine. It was the CPU and the memory were quite under my threshold. But I see that the CPU of my database actually shot up and maxed out at 100% after some time. So I see that as the load increased, the CPU percentage also increased for my products DB, which is the SQL database. And that indicates that CPU for my SQL DB is one of my performance bottlenecks. So what I did is I went ahead and I upgraded the SKU for my SQL DB. So it was on the basic tier, I moved it to the premium tier, and I ran a test again. As you can see, this time my test passed. I see that the error percentage was quite less, and I also can go ahead and see what exactly was the CPU. So this is my products DB. I see it was below 20%. So now I can dig deeper and understand if there were any other issues. I see that the number of errors also have significantly reduced. That means I'm doing better than the last time. So I can go ahead and dig if there are any other issues, but this is how you can actually use the metrics that are provided from the client side and the server side to identify what exactly was the issue. So now that we saw and try to understand how you can fix performance bottlenecks, let's see what what Azure load testing is doing when you run a test, right? So you can upload your JMeter script or the Locus script, and this will spin up the engines that you configured to run your test. So these test engines will now simulate load and hit your endpoint. If your endpoint is hosted on Azure, we can pull metrics from Azure Monitor, and that gives you a view of your server-side metrics like we saw just now. And also it collects metrics from each of the engines to help you understand what the client side experienced. So you have a single dashboard which gives you a view of both the client side and the server side metrics. We've been continuously adding more support and adding more functionality in the service. Today I'm exciting that we are soon going to release the support for multiple JMeter files. What it helps you do is you can now modularize your files. So for example, for all the different microservices that we saw in Contours for Traders, you could have a different test script. You can plug and play, run these in different combinations, reuse them across test plans. That helps you reduce the time and maintenance required for you to create tests. Another thing that we are soon releasing is the scheduling and notifications capability for Azure load testing. So now you can schedule your load test to run at a certain time or a certain recurrence as well. And then you get notified when the test completes. So this way you can enable the end-to-end automation scenario for load testing. So now we have looked at two aspects so far, quality and performance. Now I want to take it a bit further and ensure that my app is resilient. That means that if anything unexpected happens during, say, the sale, I'm confident that my app is able to respond in a way that I want it to. So we are going to see how we can use Azure Chaos Studio to do that. So chaos engineering is a scientific method that allows you to measure, improve, and maintain your product resilience through systematic and controlled chaos. Azure Chaos Studio is Azure's solution for chaos engineering. It's a fully managed service that helps you validate the resilience of your Azure applications. It has deep Azure integrations with different Azure services. There's an expanding library of common resource disruption faults that we have, and also it has a workflow orchestration. So basically you can define your experiment in a workflow, and to run sequentially or parallelly you can have different faults within the workflow. And finally, it also has safeguards in place so that you minimize the impact radius and you have a controlled experiment execution. So we'll take a look at how you can run a chaos experiment, and the best part is it also integrates with Azure load testing. So what you could do is you can simulate load to your application, you can run a chaos experiment by injecting certain faults, And then you can see how your application is performing during that time. So let's take a look at that. I'll again switch over to my demo. So you could go to the portal and go to Chaos Experiments and create a new experiment. Let's take a look at the Contoso Traders experiment that I have already. So this is an experiment that I have. Let's take a look at what the experiment exactly does. Right? So we spoke about a workflow orchestration. So this is the workflow that I have defined for my experiment. It's a simple one. The first step is to generate load. So I have a step called load, and I have certain actions in that. So I have an action called start load test. So Azure Chaos Studio has this action where you can just mention which test in Azure load testing you want to trigger. So you can just mention that. And then I have given a short delay so that my load ramps up and my test gets started. After that, my second fault that I have here is the stress on AKS. So what I'm doing, my products DB, my products API is on Azure Kubernetes Service. So I'm trying to stress the CPU for my AKS. So I have run this, I've defined it for 10 minutes, and I have selected the namespace and the specifications that I want for my fault. I have selected my AKS in the target resources, and I have added this fault to my experiment. So this is basically what the experiment does. It kicks off a load test, waits for like 5 minutes, and then the fault is injected after that, and it runs for a duration of 10 minutes, and then the fault is again closed. So now let's look at this experiment. This experiment ran, I have run this a couple of times, and what I want to show you is the load testing result that, that ran as a part of this experiment. So let's look at my, let's go back to my load testing resource, and we'll take a look at the test run that ran as part of this. So this is my load testing result. So here I have just simulated a typical load of like 200 users concurrently accessing my website. Let's first look at the CPU percentage. Since we were stressing the CPU for AKS, this is what my AKS CPU percentage looks like. As you can see, as the fault kicked in, I see that the CPU percentage increased a bit, and then it's increased even more, and then till the end of the duration of the fault it was high, and then it again got back to normal. So I want to see how my app performed during that time, and was it able to respond to the stress. So I'll go and see what the response time looks like. So as you can see, as the CPU increased, I also see that the response time for my products API shot up, but it was able to respond once the fault completed. It also got back to normal. The best part is that I also see that there were not a lot of errors during the fault. I see that there were very minimal errors, which makes me confident that my app is able to respond to the fault that I had injected, and make sure that my app is able to take any sort of disruption. So there are a lot of faults that you can simulate. This is just one example. We have many other faults that you can do. You can simulate and make sure that your app is able to handle those. So we looked at three things today. We looked at quality, we looked at performance, and then we looked at resilience. This is an overview of all that we've seen today. So we use Microsoft Playwright testing to ensure your app is high quality, Azure load testing to make sure high performance, and Azure Chaos Studio to make sure it's resilient. All of these are fully managed services that you can use to make sure your apps are robust. They help you simulate real world scenarios, like user scenarios in case of if in case of playwright testing, real-world low traffic patterns in terms of load testing, and also real-world outages for Azure Chaos Studio. It gives you reporting and metrics and the required results that you need for you to be able to take actions based on the insights that it gives. So you have actionable insights as well. And it also integrates with your developer workflow. So I'll just show you one workflow that I ran where all of these together were running in a single pipeline. So as you can see, this is, I hope it's visible. So this is a pipeline that I had in my GitHub workflow. This is the same Contoso Traders repository that we were looking at. The first step I did here was to provision and deploy my infrastructure and code to Azure. So I did that. And then the next step I did was to run Playwright tests, my UI tests using Microsoft Playwright testing. The third step that I did here was to run the product's load test that we saw just now. So I ran that. And the fourth step I did here was to run the chaos experiment along with load. You do get results as well in the CI pipeline. As you can see, this is the result for Microsoft Playwright testing. It tells you how many passed and how many failed. For load testing as well, you can see a summary of what happened during the test, like the client-side metrics for what was the throughput, the response time, and the error rate. So you get those details as well here. So we recommend it as best practice that you always have your tests integrated in your deployment pipeline to make sure that your app is working as expected before you promote it to your production environment. So yeah, that's all that we had today. If you want to get started with any of these services, you can use these links. You can learn more about the product. It has a lot of resources like videos, tutorials, and all of that. And we also have feedback forum for each of these products. You can share your feedback if you have any issues or any feature requests that you have for us. We are listening to that as well. So thank you so much for taking the time to attend this session. I'm sure it's the last session and you have some travel plans. So I'll wrap up here, but I'll be around if you have any questions. You can come up to me and we can talk about that. Thank you so much.